Regal's 7000 series oscilloscopes enhance the way engineers analyze frequency domain information in three important ways. First, the 7000 provides FFTs that utilize the deep memory of the scope up to 1 million points. This makes more complete and accurate frequency analysis of high-speed and RF signals. Second, the touchscreen and frequency domain controls and display tips make adjusting this data quick and easy. These include span center or start-end set points, peak searches, and auto-scaling. Finally, the addition of Keller FFT probability plots makes advanced analysis, usually reserved for a spectrum analyzer, possible on your oscilloscope. Let's take a look at how each of these advances improves debugging with the scope. Most important properties of an FFT are the number of points and the sample rate. These two properties set the frequency resolution as well as the max and min frequency points. So here, let's start out with our capture for 1 megahertz square wave. Now let's turn on the FFT. So now we see the FFT of the entire span. Let's scale that down a little bit. And since it's only a 1 megahertz square wave, let's just look out to 10 megahertz instead of the full band. And now we'll just adjust that. So now we can see the base frequency and the odd harmonics, the first few of those odd harmonics. Now that we've got the span set, we can easily adjust the RBW. You can see the resolution bandwidth denoted here in the RBW marker. As I turn the time control out, the RBW goes down. So the wider piece of time you're looking at, the deeper the resolution bandwidth, the better the resolution bandwidth is. So there we've seen that improve. Now, the other way we can adjust this is with the memory depth. And you can see so far we've been in an auto memory mode. So now we're using 2 million points currently. But you can see if I turn that down, 10 kilohertz or 100 kilopoints, and then up to 1 million points, you can see the noise, power, and frequency accuracy gets better every time. So this is really how memory depth and sample rate help your FFT calculations. They improve the power and the frequency analysis capabilities. Now that we have the accuracy right where we need, we can also go ahead, go into that FFT, and let's go ahead and turn on the peak search. So here we can look at these peaks across each of these tablets and look at it like you would on a spectrum analyzer with peaks at 1, 3, 5, 7, and 9 megahertz. We can also see that they're moving slightly left to right, especially at the higher harmonics. That's really because there's a little bit of a modulation on this pulse, or on this RF signal. So let's look and see what that means. So we go out further, out to 500 microseconds per division, and let's go back to auto memory depth. That'll give us 25 million points on this signal. And now let's go ahead and turn on a second FFT. This FFT we're going to scale up as well. And here we're just going to look at the 50 kilohertz right around the 1 megahertz carrier. And now we can see I've put this into Keller modes. We've turned the Keller FFT capability on. And we'll see that fill in here over the next few seconds. What this really does is creates a probability chart of the signal, giving you a little more detail, in this case in a zoomed in fashion, on how that 1 megahertz carrier is really operating. And so on the Keller FFT here, we can see the center frequency is 1 megahertz and the divisions are only 5 kilohertz per division. So we can see there's really an FSK pulse happening here that's just plus or minus 10 kilohertz from that 1 megahertz carrier. So we can both look at the main signal and the harmonics and really dig in and look at the modulation scheme within that within the core carrier there and learn more about our signal using a combination of these FFT capabilities, including the peak search, the Keller FFT, and the deep memory capability of the FFT in the new 7000 series oscilloscope.